Hi, Shed. This is Paul. We've got a situation with the deck here. It's a little crazy situation. This was originally built as a cantilevered deck, and these are out about how far, Sarge? This is probably about 5 feet out, these joists from the wall of the house, and the rim joist is rotted on it, and the next 3 feet back, you'll see upstairs, it's over living space. So the deck was always a waterproof deck, but it's always had problems, and it's been leaking and causing obviously water damage coming into the house. Since this was originally built as a cantilevered deck, it never had any post and beam structure, but somewhere along the way somebody tagged in a standoff plate for a 4x4 and a 4x4, and they put post on underneath this and just kind of attached it underneath. There's a triple rim joist, a triple 2x, and they supported it because it was too bouncy, the deck. And then also, somebody being brain smart, they went ahead and they put a poured mortar bed that looked like tile up top, and all the added weight kind of made it sag. So you also see the 6x6 posts supporting this staircase system that's over here. So that gives you a little bit of an idea of what's going on here. The railing up top, the 4x4 posts, they're all rotted. So the railing has to come off, at least that portion of it. Now, when we come up here, what we have is a deck that is overall about 8 feet out from the house to the edge, and we have a deck that is approximately 27 feet long. And if we take a look at the deck here, we have a deck from about here to, oh, Sarge, show us where the level still works. Yeah, where the slope is.
Right about here.
So right about where Sarge is. So I'd say probably out of the 27 feet, maybe about 18 feet of it, something like that. Right there, the deck does have a slope in it, and it's about, let's call it, a 1/4 inch per foot. So from here to here, the slope works. The problem is, back over here where Sarge is, it's all flat. There is no slope. And of course, this is where it's been leaking. And the way that they've done this framing, Shed, you can see, by the way, so it's more obvious, that's the back wall of the house. But since there's this wall here and that wall over here, the first 2.5, 3 feet of this are over living space. So basically from here back is living space, and that's what necessitates this being waterproofed here. And if you look back here, here's the way they did this connection. They have an upside down joist hanger that is in there. And what size is that joist? That's a 2x8. 2x8, that's it?
Yeah. Okay,
so it's a 2x8 joist, and it's going out the full 8 feet here, and 5 feet of it is cantilevered here. So, and it's an upside down joist hanger, I guess because of the pressure pulling up on it, and it sits on the right here on the plate of the wall. So the problem is, this has no slope, Said, to get to the point. There's only 2 inches from the plywood right there to the underside of the door. And in order to get slope in here, this back edge needs to be raised up 2 inches, and that would make it even with the door and cause a huge water problem. So the problem is, how do we go ahead and get slope into this whole system here? And the only way we can think about it is either to shave the existing joists or to put in all new joist and have to start off with a 2x6 or something like that, doubled up. Maybe they're LVLs or something like that to get the strength. And then do we have to use upside down hangers, or do we put them in the right side up? Tell us which way we can go ahead and do it. It would be easier from our end to put hangers in upside down, correct?
Yeah.
And do we need hangers since they're here and they're sitting on this plate? I'm going to guess if we're cantilevered, can we cantilevered with a doubled up LVL, maybe 2 of them, or a 4x5.5 or something like that, more like girders, and maybe keep this thing fully cantilevered, or do we need to go to a post and beam system down here no matter what in order to support the deck? So the question, I guess, is can we put in a new joist system and cantilever out 5 feet and have a smaller joist, go from a 2x8 to at least like a 2x6 or 6 by at the very most, in order to basically work with the slope we need here. And I guess that's the big question here, and how do we tie it into the house? So given that we're in the city of Fremont, we're going to need a framing detail on this here. And let me show you this now that I brought up the issue of the post and beam. Do we need a post and beam, or can we make it work out to be cantilevered with some size joist? And remember that on the underside, this will be a cantilevered system here with yeah, this will be a cantilevered system on here. The other thing I was just thinking about is this is the city of Fremont, and this is in the urban wildland interface district, and we get into this whole issue now that the deck may have to be Class A fire rated, and I think they make joists that are Class A fire rated, but I don't know, or fire retardant, but I don't know what the structural strength of those are. I don't think you can use, as I was talking, regular LVLs out here, because now the decking will all be non-compliant from a framing standpoint. So they have a triple piece here for what amounts to the header. So given that we're about 27 feet, I'm thinking if we had to go to a post and beam system here, probably talking 1, 2, 3 piers, and 6x6 and a 6x8, 6x10, 6x12, girder going all the way across. We're on to an existing slab. The existing slab looks like it's about 4 inches thick here. Can we tag onto it from the top, or do we have to build new piers in order to carry this load, even though it's partially cantilevered? Those are all the questions of the day here. So I just wanted to give you the view of that, see what your thoughts are, see how we can figure all this out. Okay, thanks, Shed. We'll talk to you later. Bye.